Ladies and gentlemen, good morning and welcome to the Techceram seminar where we're going to be discussing digital workflow and turnkey labs. And I'm delighted to see so many of you. My name's Jonathan Rayfield. I'm one of the directors at Techceram, and we've got a rabble actually at the front. So perhaps you'd like to welcome David Claridge from Carestream, Miles Postgate from, can you bow as well, David, please? Miles Postgate from Woodford Dental Services. Miles is a client of Techceram, and he's kindly given us time today. We have Matthias Koch from Smart Optics, who's flown in from Germany, so thank you, Matthias, for joining us today. And then our very own Richard Buckle, who is also a director of Techceram, and he has specialist knowledge on 3D printing, so he's here today as well.
So,
a few bits of housekeeping just before we start. We're going to try something a little bit different. So I'm sure many of you have been to seminars where you can text in your questions. So you might like to just refer to the questions for the panel sheet. And if you've got a question for them that you really want the answer to, and you'd like them to get you that answer, text that in. I will do my best to use the technology and make sure I can read that out, get the question to them. You might want to just put question for Matthias or question for David if you want to specifically ask an individual a question. There will be time right in the last 10 minutes. We've got a roaming mic in the last 10 minutes where you can ask a question out loud as well, in old school. But in the meantime, you can text your question in. And I've put a few prompts here about the sort of things that we think people are asking about some of the workflow that is going on. So I hope that is helpful for you as we start. So that's the first thing to mention to you. The second thing is you should see a leaflet that tells you about some of the little workshops we're going to be running on our stand today. So if you want to know about intraoral scanning, visit our stand at 2 o'clock, and David will be there doing a quick demo, hints and tips on how to use intraoral scanner. At 3 p.m, Richard will be talking about 3D printing and giving an overview of that. At 4 p.m, I'm as Icor milling machines, and our own Richard Charnock, who runs our milling centre. Techceram have a full operating milling centre that supports labs, and that experience we're really sharing with lab owners, and we hope that's helpful for you today as well. We're repeating the same tomorrow. You can see the time, so I won't read those out for you, so you can read those off. Okay. Couple of other bits and then we'll get on. You can win, drum roll, very exciting, you can win a lab audit, and we've developed a process to help labs move that transition from traditional process over to digital workflow. And we're helping labs with that, knowing where software fits in, where hardware fits in, which system is right, should I go this way or that way, and understanding that is a challenge, and we're helping labs really with that process, being transparent about solutions. We believe we've selected some of the best equipment manufacturers in the world, two of them represented here today, and we're going to be talking about that. So perhaps you might want to pose a question about why do you think your kit's the best then? And David, I'm sure you'll be delighted to handle that question. So that's it. So, Richard prepared me an excellent slide. So there's our lineup today. So we're going to start with David, intraoral scanning. David, our first question for you. Is an intraoral scanner critical in digital workflow?
Yeah, it's absolutely no. For me, the digital workflow starts at the patient's mouth with an intraoral scan. So for a pure digital workflow, you start at the patient, you go straight into a CAD system, mill, straight back to your patient. So for me, my 28 years in the lab and as a lab owner, I am passionate about the digital impression because it also eradicates some inefficiencies and issues through a traditional impression and a gypsum model process. So for me, yep, and it also helps pay my mortgage, to be honest. So yes, so start with the scan of the patient. Okay.
So David, why intraoral scan though, when traditional impressions are, they've been around for 100 years, so what's the problem?
Okay, so if I'm in front of a room of dentists, I'm not going to highlight that there's a problem with their impression system because I don't know whether there is or not. But if they want something to be more accurate, all the studies are out there. They're all in the public domain that digital scanning is more accurate. When I was at 3M, we did an internal survey. 3,000 patients that had scans versus traditional impressions. So 96% of those patients preferred the scan. Please put your hand up if you're surprised. Good.
David, let's do a quick test actually. How many lab owners are in the room? Would you just wave your hand in the air if you're a lab owner?
Okay.
Okay. How many clinicians? Put your other hand up.
Okay.
Okay, so thank you. We've got a mix
good.
lab
Good,
owners
good,
and clinicians.
So 96% of those patients preferred the digital scan. So there's that element to it as well. But also I think there's a whole ream of benefits to both clinician, patient and technician, which, you know, I could go on and on and on about. But,
But we'll move on.
But we'll move on. So should I sit down now?
No, we've got more questions for you. What indications can the dentist scan for?
Okay, so two things. Well, first of all, indications. Crown and bridge, yes. Any indication, yes. Now, I can't speak on behalf of every intraoral scanner here, so you have to check out the individual ones. I can speak on behalf of Carestream, who I work for. So, crown and bridge, yes. Implants, yes. The accuracy of implants, let me tell you this, because some time ago, it wasn't full arch. Scannings, the intraoral scanners weren't accurate enough for full arch screw retain implant work. But if you want to go online and go for Dr. Francesco Mangano's study, independent study, it showed the accuracy of our scanner being 63 microns over a full arch. So we think that's ticked the box on full arch implant screw retained impressions. Trios was next at 78 microns, still good. The accuracies are there now, okay? So we've got implants, full arch, restorative, prosthetics. I will say yes with an asterisk, not full fulls, okay? Because all the intraoral scanners can't give you a mucocompressive technique. So if you need a reflection of the sulcus and border molding, you know, you can't do that with an intraoral camera, okay? So not full fulls, but partial dentures, yes. There's case study, if you're on Facebook, there's case studies going around now with the partial dentures made out of PEEK rather than chrome cobalt. So it's all moving around now.
David,
And now cut me down. I was on a roll there, sorry about that.
I'm expecting a text question in about that. Don't forget the mobile numbers both on screen and on your sheet. Can any lab owner scan the file? Or do they need specialist software?
Okay, so there's a huge thing on open files and what is an open file. My definition of an open file is an intraoral scanner that can emit an STL file or any other file format without fees to any lab system. However, we have to put an asterisk there and say, is your system at your end in the lab fully open? And that asterisk really pertains just down to one supplier, which is 3Shape, because there are levels of openness of 3Shape. So you just have to make sure that you've got a fully open 3Shape system that can open up to all the intraoral scanners that your dentist will be sending files from. Okay, Exocad's fully open, Dental Wings is fully open. We've got instruction information for you to import into your system. So if you've got 3Shape and you're not sure, if you haven't got an inbox and a model maker software on the end of there, then you're kind of selectively open to us. So it's not a straightforward yes or no. It's a case of, you know, if in doubt, let us know. We'll send you an STL file and instructions to import into your system and then try it.
And I think that's a critical point, isn't it? Actually, let's test that and we'll work with you. Carestream and Techceram will work with you to test that to make sure that that is going to function for your lab. Okay. We're going to talk about Exocad a little bit now, and that's a wee bit open to the floor, but Miles, probably the most experienced of our panel in terms of Exocad. No pressure, Miles, at all there. Tell us everything about Exocad. No. What intraoral scans can be sent in open files to Exocad? Can you tell us? Welcome,
I should just mention at this point, everyone here is a professional speaker but me. I'm just a lab owner. So when I get it wrong...
Should we give him a round of applause, I think, for turning up, actually? Thank you, Miles.
So when it goes hideously wrong, come and ask me later on the Techceram stand, and I'll give you the real answer, the right one. But we've used Exocad for a number of years now, and we've never had a problem importing anything. So it doesn't really matter where the file comes from. It's fully open, so we can open it. If you can get the file to us, we can open it and we can work on it.
So my next question was, what can the lab do with the STL file? And the answer is?
Anything. There you go.
Okay.
It's, so I can enlarge on that. It's whether you want implants, beams, porcelain bonded to metal substructures, we can do ortho appliances, and it's basically the software is just continuously rolling out. At the moment, I think one of the latest things we've just done, we just managed to figure out how to 3D print an implant model. So from that, we can, you get a very, very fantastically accurate model. And then we can have the custom-made abutments on that. We can use Exocad software again to design a substructure that is going to get cemented over the top. And the accuracy of these things is just superb. But again, going forward, I don't know whether I'm meant to sort of talk about this, but I know at the moment we're actually looking at doing drilling guides where we're taking the cone beam scan and matching them together with the intraoral scan. You can put them together, so then you can look at that. It's crystal. We put a tooth virtually in place, a crown in there, and again from that we can design where we want the implant to go. There's still a few issues with it, but that's kind of the next big thing coming from Exocad, and it is happening. It's well underway now.
Great, and we'll talk about the join up with that and 3D printing in a moment. So thank you, Miles. How do you see the future for treatment planning in terms of Exocad?
I think it's one of those things that we've been placing intraoral scanners into surgeries, and we've actually been, we're not tied to Carestream, but we've been placing Carestream scanners into surgeries, and the feedback's just fantastic. The dentists love them, the technicians love them, and so I think, as you say, the future, it will be from intraoral scans. Can't always be the case. We've already had cases, obviously if there's a post core there, the scanner can't see what it's doing, so they go back to an impression. Sometimes if there's that much blood or soft tissue flapping around, they'll still take an impression. But at the moment, that's the way I'm looking at it's going forward. Just to bring on something David said, with the milling of dentures or 3D printing of dentures, Exocad is actually, the software's already evolving, so it takes muco-compression into consideration. So whilst, did you know this? So whilst it can't be done at the moment, it is in development, that the software will take it down. So again, dentures are on the way.
Okay, thank you. That's really, really interesting insight, and we're excited to talk about this, and we'll be sharing more of this information as we learn. Over the course of putting this presentation together, one of the discussions we had was that we know lots of answers, but we don't know all the answers, and with each lab owner and clinician we meet, everybody's got a different way of working, and it's kind of making sure that mix can work for your lab or for your clinic. So we're going to look now at lab scanning, and Matthias, we've got a few questions here. Where does the lab scanner fit in the digital workflow?
Generally, it's the first step in the digital workflow. Without the scan, it's not possible to do other things like regarding of the CAD software, of printing or milling. So it's a first step, and it's necessary to use it. And the benefit of lab scan is often you can use it very fast and very easy to use it, and it's a really good technology since more than 20 years. Okay,
so once I've got my question up on the door, once I have my scan, what can I do with this? So I've put my traditional impression into your scanner. I assume traditional impression. Are we only talking about traditional impressions, or we'll talk about printed ones as well? What do I do with that once I've done that scan?
Of course, first of all, you can do it with the scan. It's a basis for make your own modeling, crown, bridge, and so on. But you can storage the scan too. So it's not necessary to storage a Gibson model. So it's possible to save the scan. So you will save a lot of space, and of course you can send it to. Can you use it for all CAD softwares with import of STL?
Okay, we had an account recently where we were talking with a lab, and somebody had been asked to go over and collect their traditional models, and they sent a Luton van down. They said, we don't know how many there are. The van driver at the end of the day took a picture and texted it saying the Luton van's full, and that's the warehouse, and there was about 5 times as many still in this warehouse, and I guess this is really what we're aiming at solving. So there we are. Okay, so is there a reason, Matthias, that I would scan a 3D printed model?
Yes, it's possible, and I think that's very important to scan, because to make sure the restoration is fit. and fitting what do you do, and of course to storage the models in the future too. So you can scan it without any restrictions. Yeah.
Okay, thank you. And then lastly, it would be rude of me not to ask you whether you've got any innovations that are on their way that you can tell us about.
Yeah, about the latest develop, it's the vinyl scanner, it's a model scanner with an...
This is the vinyl scanner.
Vinyl, right,
yeah.
right, it's the model name. So sorry, I'm a German, sometimes...
No, we're pronouncing it wrong. We call it vinyl,
bad
it's really it's the vinyl scanner, just so you know. Okay, Matthias, thank you.
And this is the sole scanner with real articulated measurement. Means you can put your articulator directly into the scanner. The scanner know which kind of articulator are you using, and then you have directly with the exact position from upper and lower together the scan. So you know the movement. If you use a face bone, you know the movement and the modeling. And the benefit is if you know the all the points, you can see it during the model process, whereas the contacts. So if you know the contacts, you can consider it during the design process. That's the biggest benefit. And it's fully automatic. It means it's very easy. You take your articulator into the scanner, push one button, and it's fully automatic. You don't need any plates. You don't need to screw something or like this one. That's the first. The second benefit is you can use it by touch display. So it's not necessary to use the keyboard. You don't have to watch at the screen. You don't have to use the mouse. So you can use it directly. You can concentrate it to the scanner and to the scan process. So that's the reason why we said it's a workflow champion. Of course, you can scan impression. Of course, you can scan multi-die. You can scan in colored and so on. That's normally. But I think the biggest benefit is you save really time to use the touch display. And of course, it's very easy to use regarding of the real articulated measurement. And real articulated means not clip-clap. So we talked with SIM, we talked with Gamma, we talked with Arman Gierbach to make sure we have the exact positions from the articulator and we can transfer the exact all these informations.
Okay. Has anyone seen the vinyl, by the way? Has anyone seen one? I had the opportunity to go out and meet Matthias out in IDS Cologne. It's a very cool bit of kit, so if you are looking for a new lab scanner, that one's worth looking at, just from a style point of view, dare I say. Anyway, right, we're going to move on now and talk a little bit more about 3D printers. So we'll bring up our next set of questions for Richard. First of all, Richard, do all the 3D printers do the same job, and do they all work in the same way? Can you tell us about 3D printers? I guess some lab owners, you may already have them. Others, you may be thinking of where you start with 3D printers. So if you have, Richard.
I think I'll answer that with a history lesson, actually. So you okay for me just to wax for about 5 minutes on history of 3D printers?
You've got 3.
I'm a bit more of an engineer than a sort of on the dentistry side. But so the original 3D printers, would you believe that over 30 years now 3D printers have been out? I think it was 1984 that they were developed. I'm going to name a few competitors here. 3D Systems developed them in the US. And there's lots of different technologies. There's about 7 different types of 3D printer technology as well. And really until recently, until about probably about the last 3 or 4 years, you've seen a lot of larger printers, industrial printers, specialist print companies. Particularly in Germany, there's a really massive market for bureau services for printing. So 3D printing was adopted quite a while ago in Germany, in the US as well. And but then lately the market just changed really, only in the last 1 or 2 years when Formlabs came out with a smaller SLA printer. So you'll find that there's probably 3 or 4 different technologies that you'll see in the dental market. We still see FDM, which is fiber deposition, which is the reel of fiber. It's like a resin fiber. You'll still see that in some countries. It's a low-cost printer, probably under £1,000. SLA sort of disappeared really from dental. It was really multi-jetting. The big American brands, a lot of them were using multi-jetting, and now it's come back into a sort of cost-effective printer that you can put on the desktop. So that's SLA, stands for stereolithography, and it's a liquid resin that is cured with light, photosensitive light. You've also got another technology called DLP, which is basically digital light projection, which is mirrors, which are projecting light onto liquid resin and curing that. And then there's another crossover one, which is arrays of LEDs that basically just flash and cure. But the technology that seems to be dominating at the moment is a liquid resin, really. And we're seeing resins coming out all the time to replace the traditional materials that are being used in the labs and in the clinics. So it started with model resin to replace the traditional study models and working models. You've got even different types among those resins. So you've got like a sort of resin type finish, but then they're even bringing out stone type finishes. So you hold it in your hand and it actually looks like the stone impressions that you're all sort of used to. But then we're seeing surgical guide. Now you can print surgical guides, whereas people were making those before. And the list goes on. Dentures aren't going to be too far off now. Crowns is just the most amazing thing now. There's a company here who have got a small printer about this size, and they can print crowns, a very small build area about this big, and they can print crowns in, I think it's 8 minutes, and even select the color shades, different Vita color shades. I mean, it's an expensive piece of kit, but it's absolutely amazing. You know a little bit about that, David, and I think you feel it fits in with the intraoral scanning, don't you, David?
What I would say is, as a lab owner, look at volume as well. You've got some of these beds that are quite narrow and quite a slow build. But what I'd say is when I got involved in digital SLA work through when I was at 3M, so 8 9 years ago, we launched the Lava chairside oral scanner, and there was an SLA model process. Those lines, that it's made in lines, it cures in lines, they were around about 150, 200 microns each line. It looked almost corrugated, at that stage. So if you're doing a central crown and bridge technician, so you want to match the surface texture, you couldn't get that off an SLA model. That's all changed now, But also there is a different way of working. You can get the pictures and stuff to look at that. But these models now, 25 microns now?
Or lower, yeah. But the other thing is, David, we find that you don't need that accuracy because the digital scan is so accurate, and it goes through, say Exocad for your planning and your design, and then printing, you're cutting out all margin for error.
Yeah.
So I think clinicians had in mind 19 microns as being that sort of target figure, didn't they?
Well,
but that was because they're starting with something that wasn't really that accurate.
And it's a wry smile on microns. I talk about microns nearly every hour of every day now, and I in the intraoral scanner world, we're comparing. So our Trios friends, an ADA study showed that over three units, they were a deviation of 7 microns. We were 10 microns. So we failed dismally by 3 microns. We're going crazy over microns now. From the intraoral scanners, they're all accurate. But what's really unblocked it for us is the accuracy and the affordability of 3D printers.
Miles, you've also gone on down this journey as well, because you're now working with a clinician who has taken a Carestream intraoral scanner and sending files through to you.
Yep.
And you're just about to step into 3D printing with the microlay unit from Techceram. So just tell us why you decided to take that step too.
I think it's the issue of once you've got the intraoral scans coming in, you must offer the 3D printing. If you don't, you can't do any of the high-end products. What we found, and I think for all the lab owners out here, has worked fantastically well, is we can grow the business from the intraoral scanner, because we get a scan in, from Carestream scan. We can design and make a crown, and it's ready to mill in 3 minutes, something like that, and it's that quick. But I don't just want to do NHS crowns. I've now got the technicians sat there with nothing to do. So we've got to 3D print those models. So then we can do our lava crowns, our Emax, and veneer over and make those bespoke, sort of the high-end expensive crowns. So that's why we've gone down that route. It was basically, without it, we couldn't function. You do need to be able to offer right across the board.
Okay. Richard, we've got a number of 3D printers, or there are a number of 3D printers on the market. Can you tell us a little bit about the suitability of different types of printers then for applications? Because it's all very well saying buy this one, it's the best, but it's not as simple as that. It's about deciding, well, what is it you want to do? So what framework does a lab owner need to use to go, well, what do I decide to buy, and why would I make that decision?
Yeah, I think all the printers on the market now are doing study models, so you'd be fine with model. So it's very much about what you want to do. Not all printers do surgical guides, so your choice would be limited. I mean, one of the biggest things is speed. So probably the most common 3D printer on the market, which you're probably aware of, is taking about 3.5 hours to do a build. And that's because it's SLA, it's got a laser which has to follow the path, but it has got a good range of resins. We're selling a very, very fast printer, probably the fastest in the world at the moment, from a Singapore company called Structo. And because it cures the resin in one single flash of an LED array, it can print 12...
Richard, an LED array, for those of us who might not know what that is, could you share more?
Really? Okay. At the bottom of the printer, LEDs, which are light-emitting diodes. So look around, all our lights now are going to be converted into LEDs because of the EU directive. These are just little chips, little diodes, and there's about 900 of them on a base plate, and they just flash. And as they flash, they cure the resin, and that's one layer cured. And then it doesn't matter whether you're doing 1 arch or 30 arches, it just cures in one go.
And that's the technology that gives us the speed, is it?
Yeah, so that's probably the fastest there is at the moment. And with that printer, you can do study models, you can do molds for aligners and for retainers, and then there's other resins coming as well. So there's the surgical guide, there's custom tray, and it just goes on and on and on. So it's really, you need to work out really what your budget is, how many models you want. So these are conversations we have, don't we?
Okay.
How many models are you
budget,
doing?
number of models.
Number of models, what sort of time, how are you working, what your sort of workflow is. Are you going to want to interchange different types of resins? If you are, you might be better with more than one printer, so you can dedicate printers to certain tasks. If you're a lab or even a clinic that's doing just a set sort of type of job, then you can probably stick with one printer.
Yeah.
So, I mean, I'd say come and see us. We'll give you advice. We'll give you impartial advice. We might even mention some brands that we're not selling. We're happy to do that. It's probably one of the hardest areas now because we did about 12, 18 months worth of research on 3D printers. There's about 50 brands out there, and every day a new brand comes out, and it's very difficult. Whereas on intraoral scanners, there's really only about 5 brands, and there's only one brand, sorry. there's about 5 brands, but there's really only one brand. And even on lab scanners, there might only be, say, 10 brands that are really, and only one brand according to Matthias. But it's maybe an easier decision. But 3D printers is really difficult, isn't it, for some people to decide.
Richard, what about resins? Because again, you just touched on resins a little bit more. I mean, let me say, Richard's knowledge on 3D printing is extensive and materials, so please go and come to stand GO1, ask him some more questions. Yeah. He's got lots of answers, and if he hasn't got them, we'll go and find out for you. And that's one thing that, as a business, we endeavour to do. If we don't know the answer to the challenge that you've got in your lab, we'll go and try and find that answer out, and we'll come back and share that with you. And we see that part of good practice for us as a business and building good relationships with you. But tell us a little bit about resins for a moment, and what resins I should choose, and biocompatibility and all of that stuff going on.
Yeah, so biocompatibility is a big topic of conversation now. So when the resin is directly being cured and then going into the patient's mouth, or indirectly if it's being used for aligners, we just need to think about whether it's biocompatible, whether it's been through all the tests. So you've obviously got class 1, which is for a short term in the patient's mouth up to 6 months, and then you've got class 2A, which is 6 months and over. And there are resins coming out which meet both classes. Obviously, class 2A takes a long time to develop because you need to be, if you're a resin manufacturer or a 3D printer manufacturer, you've got to wait a long time to get that resin approved. But it's a real issue, and I think these are the things that people need to really be thinking about. Have these resins got the certification? Because if you go on the internet, you can find resins probably as cheap as £50 for a litre or a kilo, up to £200, that's £250, £300. That's the price range. But just be careful when you're looking. And so it's really important that you buy from reputable brands and you look at the certification of the testing, because we've all got a responsibility to, and a legal responsibility to make sure that we protect our patients. Some of the leading brands of resin producers. There's four or five leading global producers of resins, and they've probably got 12 to 15 resins now in the range. And there'll be 5 or 6 biocompatible resins. So there's Surgical Guide, there's Bite Splint, there's IBT resin. All these resins, once you printed them, the resins, these liquid resins, once you printed them, they need to be cleaned in IPA. And that could be anything from 50 to 99% IPA solution, just to clean the oh, you're on that now.
Yeah,
okay.
Sorry, we just jumped to that.
Okay.
I apologise. Not very
That's
slick.
all right.
of me
You'll see
there.
it coming up soon.
But
Shall I keep talking, or do you want
yeah. Richard, well, tell us what's going on. That'd be great.
So here, this is the Structo Orthoform. This is the fastest printer at the moment on the market. You can print up to 30 hanging arches in 90 minutes. But if you lay them flat, you can actually print in 28 minutes. You can print 12 interlocking arches. After that, you take the arches or the study models off the build plate. You pop them into the IPA that I was talking about, and about 10 minutes to clean them. Sometimes 2-stage washing, and they come out clean of all residue. And then they go into a curing oven just to harden and do a final curing process on the resin. And the same then you got specialist UV curing ovens for curing to biocompatible standards, and that's obviously what I was referring to earlier.
Okay, thanks, Richard. I mean, we see that as really critical. That it's all right having this technology, but actually, is it safe? Is it suitable? Well, again, Phil Evans, our managing director and founder, is a specialist in materials, and this has been a subject that he's been exploring for some time, and by all means, again, come to our stand and talk to us a bit more about that. Now, one last thing, Richard, on Structo, which perhaps we could just jump back for one moment and see. You wanted to just tell us a little bit about this new unit, which is about to come onto the market when? This is coming out now this month, so we'll have that available. It's not on the stand, but we're taking orders now. This is the next progression. And this is even faster, even more accurate. And so the original printer was called Orthoform, prints at about 100 microns. This is printing at 50 microns or better. So the more accurate the printer, obviously the more choice of work, the range of work that you can do. So I mean, what would you require, David, to be printed really accurately? I guess it's crowns, isn't it?
Yeah. If I can get some microphone on there. Yeah. I just hear feedback from the market that you want around 20, 25 microns for a full arch. Would anybody say yeah with your printer? So that can do, but then there's another question in there, is if you're doing implants now. So our scanner can scan any scan body you put underneath it. We're just taking pictures. Then it goes to Miles in his CAD library. As he says, he can design on there, but you do need a verification jig, which is your 3D printed model. So that model now needs a soft tissue model. So the various materials that Richard was talking about, you can get ginger fast printed now, and you get metal analogues into those. Not all the printers do those, so this guy knows all the printers, So talk to Richard about which printers can give you a metal analogue inside a printed model for your implant work, because that wasn't there 2 years ago, it is now. So again, horses for courses.
Yeah. Okay. We're going to talk a little bit about milling now and moving on to that. So if we can go on to milling machines. And again, unfortunately, Sebastian from iMosaico was unable to join us today, so we apologise that he was unable to make that. But Miles, again, has kindly agreed to answer every technical question you've got. To help us out on milling. And Miles, what milling machine is it you have?
We have a iMosaico 350 with a changer on the side, the 12-disc changer as well.
Okay, so what can that do?
Replace staff and save a lot of money.
Okay, replace staff and say, off the record, this is what it can do.
It basically claims that it can mill anything, and it can, but genuinely we don't ask it to mill any alloy. We only mill in a soft state. And my mind thinking on that is, well, if we've got this thing, it mills in a soft state, it will last forever. But because it's got the 12 disc changer, we can basically go home on a weekend and leave this thing, and it can just mill and bang out crowns. But the big things that, and I think for all the lab owners,
and you do that, you leave the machine to run over the weekend.
Oh, we do, yeah.
You come in Monday and there's your billable work, effectively.
Absolutely, yeah. It's but what we found is, and I think for the lab owners it's a really big plus, we found we can really grow the business with the staff that we've got, because we're using the milling unit to make the crowns. So all the guys have to do, and for all the technicians there, it might take you sort of 5 minutes to design a crown, then it's milling, and you can go and do something else. So it's, I was talking to someone earlier today, and they were milling wax substructures, and then they were investing them and casting them to do porcelain bonded to metal. And my response was, well, why are you milling wax substructures? Because then you're still trimming it up. Mill Syntec K, the equivalent, I don't know whether you've heard of Syntec K, is Syntron, and it's an alloy that comes in wax, and then you put it through an argon firing cycle, and it comes out as alloy. We're doing full metal crowns or metal substructures. It's fantastic. So all you do is you get your technician to design that. You can do a nesting scan. I think it's about 10 or 12 crowns at a time. Maybe takes you 10 minutes, and suddenly you've designed 10 substructures in 10 minutes, send them to mill, they get fired overnight, and I'll promise you it's 2 minutes per metal substructure. You run around the metal margin, give it to the ceramist, he sandblasts it and puts a porcelain on. If you're doing a bridge unit, there's no stresses to come out of the alloy, so it won't distort. So you can fire the porcelain as many times as you want. You're not concerned that it's a bridge unit and it's going to go horribly wrong, and it'll warp. It just won't. So you end up with better porcelain. So the ceramists are doing a better job. It's a quicker job. And then also now I can ramble on. This is
No. This is good stuff. Go on, please.
One of the biggest things that we found, and we basically advertise now that we're replacing all porcelain bonded to metal, all full metal crowns, with a Techceram product, Adite, and it's multi-layered zirconia. Now, there's loads of multi-layered zirconias on the market, and they all advertise how strong they are, the 1400 megapascals, and I'm sure a lot of you have tried to trim zirconia, and you cannot trim it to save your life. Well, this is 600 megapascals. They've even got a trimming kit that they've put together that goes with it, so it's relatively soft. Dentists can adjust it, you can adjust it, but what we're finding is we'll either take a traditional impression and just scan a very simple model. We're not going to cut it up or do anything with it. Just pour a model. We tend to just pour the prep in dye stone, the rest in the cheapest stone that we've got. We'll mark the margins, we'll scan that, and then we will design a crown from that. What we found is, and I'm a metal worker, so I think I never get anything wrong. But we've halved the amount of remakes by not putting a metal substructure on it. Nobody's waxing up on it, nobody's touching it. And when that crown goes to the ceramist, paint a bit of glaze on it, goes out, it's done. But equally, now with intraoral scans, and this is why we're pushing these out. And as you say, other intraoral scanners are out there, and I'm happy because we can accept any scans because we've got ExaCAD.
Yeah.
It literally, I've sat there and shown the guys an intraoral scan comes in, you mark the margin, you design the crown, and it's ready to send to mill. And I reckon you're talking 2 or 3 minutes from getting that scan into the lab. So it's in the milling machine, we cut it out of the milling disc, it sinters overnight, glaze and away. So suddenly we're out there, and as I say, I just think it's great for lab owners. We're taking on new clients, but I'm not taking on staff. We've got capacity. And from the dentist point of view, the price of the crowns has absolutely crashed. So
Miles, my question was, what's the capability of the mill on a modern lab? And you're saying growth.
Absolutely, and it's that thing that we're growing the lab. As I say, it's so price efficient. And as you know, I always carry a little pocket full of crowns around now. So if you want to see
It
a
looks
crown,
a little sad the first time you see him do this, but
I have got a
would you like
pocket
to
full
see
of
my
crowns.
teeth?
Got about 20 crowns in my pockets. You can come at the Techceram stand, you can
it's
have
when you
one.
go out socially and he does it. It's just very unpleasant. But,
Don't you? Doesn't it? It's perfectly normal.
In a work environment, fine.
But it's, and I've actually sat
Can't
there
buy
with
a
a group
pint.
of dentists, and I just love this. They're all it was my dentist to practice, and I showed them this 8/8 crown.
Yeah.
And so it's prettier, it's stronger, and it's cheaper. And one dentist who places them, and no one else does. You'll never get the black line. It's bio-inert. So this is just, it's translucent. This is a winner. It's soft that can alter it.
Yeah.
And the dentist sat there and said, so I'm placing these 8/8 crowns. None of the rest of the guys are. If someone comes in and goes, I've got this black line, where do they stand on that? She goes, do they plead ignorance or just lazy? Because in her words, it's better. It's better in every respect. It's fit, pretty. It's an all win.
Yeah.
And we're growing the lab off the back of it. So
And it's great, isn't it, combining the technology and the materials and, again, having that range of materials in order to do that, to get that excellence. And it's all about, aiming at better work and more excellence from the intraoral scanner going, I can do a proper impression that the quality of cannot be faulted. The tests, for, David, that they've done on the CS3600, of 9,500 scans, how many were had to be redone?
I'll wait for my man. All right, yes. So
20, was
we
it?
rang around at the beginning of last year, so it's well out of date now. We need to do it again. We need to ring all our users in the UK. So we got right through to about 2/3 of them. January last year, 9,500 crowns, 22 remakes. Those remakes were all the same issue. So one thing, we can get to the bottom of it. You can find out what it was. It was all down to the lab. I'm now going to throw a bit of a spanner in the works on 3D printing, because out of those 9,500 cases, only 100 required models, because a lot of people have gone model free. If it goes into Miles's CAD-CAM process, the question mark is there, do you need a model anymore for a posterior? Let's say keep it out the smile design area, but for a posterior, full contour, restoration. So those 22 remakes were because the contact points are gone, because you trimmed it after it had been milled, but you've lost your verification because you're working blind without a model. So it's a moot point. It could, you could embrace it, it could frighten you, but the high street's kind of gone that way. So yeah, speed of turnaround. The other thing I've mentioned is the communication with Miles's lab. It takes 3 minutes to get our intraoral scan into his lab. So if ever a dentist is looking, thinking, I'm not sure I've got enough occlusal reduction, well, one thing, there's a measurement tool on our scanner, why doesn't he use it? But the second thing is, send it off to the lab. If the lab can verify your scan is okay while the patient's still in the chair. I worked at a dental practice and I started in, 5 years ago. It's about 32 years ago.
Second career then, David.
Absolutely. And what you didn't want to do is walk, there's 2 of us in the lab for 6 surgeons, a private dental practice in Newbury, and what you never wanted to do is go down a reception or the practice and say, we need to get the patient back in. You used to fill you with fear because, because I was a 16-year-old apprentice and scared of them, really. And I never wanted, when I then moved on and ran my own lab, I didn't want to pick the phone up and tell a dentist to get a patient back in. Now really, you can have that communication before that should ever arise. So anyway, 9,500 cases, that was January last year, 22 remakes. But here's the icing on the cake. Those remakes were done on the original scan. So out of 9,500 cases, no rescans. So we think we're going to be at about 24, 25,000 cases now. We need to ring everybody up again, and see whether that's the same.
It'll be great to get that research, and maybe, I'm sure, David, you'll share that with us on WhatsApp and various other places that you share.
Absolutely.
Richard, question. Thank you, caller, whoever you were. Question for Richard. How much is a 3D printer?
Oh, okay.
What does it cost?
You can actually buy a Chinese SLA printer now for less than £1,000. You might even see one here, I'm not sure, possibly. And they range in price, from £1,000 up to 100,000 plus. It very much depends on what your requirements are. Who asked the question?
Well, they may prefer to remain anonymous.
Yeah, come and see me afterwards.
Yeah. Okay. In terms of the different materials, I think, Miles, what would you say? Can you give us the extremes in terms of materials you can mill? Just going back to that for one moment.
Well, one of the interesting things, we used to do a lot of zirconia substructures, and we used to send them to Techceram. I'm not saying you're expensive, but we bought the milling unit, and on not sending the substructures out, that pays for the milling unit.
Can you switch his mic off, please?
And now, so it's all right, it's back. You know, you've sold me a piece of kit today. But now, on the back of that, we've bolted onto that, and we'll mill wax, as I say, Syntec K, the metal in a soft state, PMMA. But these are things, when we first got this milling unit, you think, well, why on earth am I going to mill PMMA? We can knock up a temporary acrylic in just half an hour. Anyway, we just scan it and we mill it and it comes out, give it to ceramics, they put a bit of glaze on it, and it looks like a private crown. And we've even milled, this is when maybe I've been a bit caught short at work, but I'll do a diagnostic wax up. It's easier to scan the model, design it, mill the white wax, glue it on the face of it, paint some, I think it's a Yeti product, a light cure glaze on the wax, and it goes out and it looks stunning. As I say, I know sort of the milling units you guys sell, you can do titanium, you can do chrome cobalt. We tend not to bother. The amount of beams and implant abutments we're doing sort of several a week. For me, it's not enough to justify wrecking our machine. I'd rather keep. One of the big issues is if you want to use the same machine on different materials, you've got to clean the machine down really, really well after you've milled alloys.
Yeah, and it's one of the reasons why we avoid wet and dry. So, you know, I'm as ICO will say you can mill wet and dry, you can, but it does make cement. So as long as you don't mind really a lot of work cleaning down, then go for it. If you need to mill wet and dry, we'd recommend, you know, 2 separate units. Make sure you get that mix, and perhaps one of them is primary. Okay, we're almost done. I've got one more slide to show you, and then we're going to see if there's any more questions from the floor. Okay, I wanted to talk to all of you really about this because we've got obviously intraoral scanning, we've got 3D printing. I could have put the other equipment manufacturers up there, but Exocad, Hyperdent, Medentica, the relationship between how you digitize your files now. We've got analogs in there, we've got crowns, we've got temporary crowns, we've got scan flags in there. Where does all this fit in? How does it work? And how do we help a lab and a clinician, and the lab giving the clinician advice? How do we make that all work? Now, Miles, you joined us down at Techceram a couple of weeks ago, and we had Richard Charnock, who runs our milling centre in. And we had a merry 3 hours, I think, talking through the relationship between that intraoral scan coming in, a little bit to do with implant work, but it wasn't just about that. And I'd be grateful, Miles, if you kick off maybe just your conclusion of where we ended up with that discussion, please.
Do you want to prompt me a little bit? All I remember was sort of basically when we cracked, Richard had cracked out to do the implant models. Yeah. And that's where Medentica came into it. And as I've said to sort of anyone I've been talking to today, one of the great things is with Techceram, as opposed to being tied into, if you use 3-shape and they'll put you down the 3-shape route, you cherry pick all the best and what really works. But that was a big moment for me.
Sorry, you said, I didn't quite hear that. You said Techceram cherry pick the best of what really works.
They absolutely.
Just in case the audience missed. He's not paid by us, by the way. But
the discount I'm going to get off that kit. But on a serious note, it was we bought this scanner 10 years ago, and then since then, every time I've looked,
Matthias, time for a new one, I think.
Well, every time I've looked for a piece of kit, and I really research these things, and then I go to Techceram and they're like, oh, we've got that. You think, why did I waste my time? But it's just the way it works. But it's always, as I say, it's moving on. It was when you crack the implant model, you think, this is great, we can do this. And to be honest, it's really easy. Anybody could do a 3D printed implant model. There's nothing to it. No. But then the next thing is, as I say, we're going on a cone beam scan coming in from wherever, an intraoral scan that can then be put inside the skull, and then you can design your drilling guide. And that's what we're on at the moment. Yeah. But it's pretty impressive the way things have come along. One of the things, just when you were mentioning the 3D printers, it does depend on what you do. Where we do prosthetics, we do everything, but generally with prosthetics and crown and bridge. And we'll accept small arches of 3D scan, of intraoral scan. We'll then just print a quadrant model, and you can actually design the models. So there's a little articulator pegs on the back. So if we're doing all those high-end cases that you worry, might not fit on a little quadrant, well, they've already thought that through, so there's no issues there. And that's something that's relatively new to me.
Thank you, Miles. I'd like to really spend more time with us discussing this, but our time's almost gone, and we've got one more question in, and then I would just want a few minutes to see if any more questions come from the floor. Richard, again, a question for you. What is peak material, and
Really?
do we need it?
Really? Peak is, I can't remember the chemical formula, but it's a polyethylene something ether ketone, something like that.
I'm impressed already.
Yeah, I
It's
know
okay.
that. I'm more of an more on the technical side.
You can mill it.
You can mill it. yeah.
It's, we've used Peak to I think is it Beaver Dental that brought out the BDT technique, and they inject Peak. Well, we mill it. So basically, it works really well because there is a little bit of flex in it. So as opposed to using so I'm looking to talk to whoever texting. So rather than having a titanium beam, you can have this plastic material. It is very, very strong, but it acts more like a natural tooth. So it does have a little bit of flex when going into the implant. Exactly the same as a bone. So the theory is you get less breakages.
Okay, if I can add to that, then there's a dentist here, Craig Parker, who's doing a talk tomorrow, I think it is. And he's got, half his talk will be a CDT, and they particularly looked into Peak and those kind of materials. And I know that Leeds Dental School are doing a study now on the longevity of a class bar made in Peak as opposed to chrome cobalt, I would love a study on the torque impacted on a tooth from chrome cobalt versus Peak. So it's all coming along, it's moving on. The problem you have is moving on so quickly, it's keeping up with it, But
Just jumping back to the 3D printed models for one moment, and the requirement to make sure that there's enough movement of gingival margin so that if I put my crown in, I can get that in, Miles. What was our conclusion there? Because that was fairly significant. I felt that when we were looking at one model, there was printout of soft tissue. And in talking to Richard Charnock, we concluded, actually, that wasn't necessary. So is it or isn't it?
Yeah, it is. In my opinion, yeah. Because
In your opinion, it is?
Yeah.
Okay.
Well, I'll be
So
honest.
that comes over to Richard to say, is there a resin that will enable us to print a soft gingival margin so that when the crown goes in, you can check
Yes,
that?
available
So
now, yeah.
there is one out.
Yeah,
So
yeah.
whether you do or whether you don't, there's a solution. Okay, so that's good. For those of you who are texting shy, there's a gentleman at the back there.
As a question for Miles, earlier you mentioned that you put scanners into the surgeries. I just wondered if you could expand a bit on that, please.
Right. Yeah, it's basically what we've done is we've looked at what people. Well, I suppose if I go from work this backwards, one of the practices we deal with, busy NHS practice, 5 surgeries, and I looked at their lamp bills and basically looked at the price of an intraoral scanner. Roughly, it was about £18,000, and deduced if they swapped onto using these different materials, they'll save between £8,000 and £10,000 a year. But what was really interesting, and it sort of comes from David, that doesn't include any remakes. The time it takes to fit a crown from an intraoral scan, every time will go click. That's it. It's not, you get one and you're trying to grind it in. It pops in every time and you get no remakes. That aside, you will still, and this 5 surgery practice would save £8,000 to £10,000 a year. So I wandered over, had a word with them and said, well, look, how about I give you one of these? We don't reduce our prices for 18 months. When it's paid for, you keep it. Then we drop you onto, I think, might shoot myself in the foot, we charge about £42, £44 for a porcelain bonded to metal crown. And I'll give you one of these crowns on the way out with the what we call the zircon crowns.
Come and see us on
I've
Stan
got
Geo.
loads I've given to
Miles
everyone.
has a boat full of them. So,
And the deal was, right, after 18 months, you keep the scanner, it's yours, we'll reduce the crown price to £30 a unit.
So this is a really interesting model that Miles has put forward here. That and Miles, it's probably fair to say that you had a few moments of like, do I really want to do this? This is a big ticket item. We know how expensive intraoral scanners are. Even though we've got a bit of an offer on Stan Geo 1, did I mention that? That you might want to talk to us about. But actually, getting your lab busy by getting the clinician to embrace digital has to be the way forward. We identified that as a milling centre. We wanted our labs to be busy, so as a milling centre, we contracted with Carestream to distribute their product so that the labs could get busy. Miles, along with your lab, we work with many other labs who also are now talking to their clinicians about getting a Carestream intraoral scanner, and they're already starting to be busier as a net result of that because they can take their file. I spoke with a lab today who just said they lost their biggest client because somebody else could accept the STL Carestream files and they couldn't do it. And they were on our stand today going, right, what do we do about getting one? It's that important in terms of this digital workflow, and this is why we've gone down that route. Any more questions quickly? We've got a couple of moments left. Okay, well, if no more questions, thank you very much, everybody, for coming today. I hope you've enjoyed interaction. If you'd like to come and see the same performance, possibly with some different answers and questions, hopefully the same answers, but maybe different questions and answers tomorrow, we're here at 3 p.m, so we'd be delighted to have you over. There is information on your chairs. Please take that away. Come and visit one of our workshops. We've got those going on. David Claridge is then speaking over at the other auditorium in
15 minutes.
In 15 minutes. And again, there's a little bit of a promotion. You've got a preview of that for Exicad. David will be talking more about that then as well. I think we should give our panel a round of applause. That will be appropriate. So let's thank them. Thanks also to our AV team, guys, for juggling that great work on the fly. Not really sure where we were going to go with that, so thank you for that. And thank you to you as well for participating. We're delighted to have a room full. Please come and visit us on the stand and have a look at our printers, our resins, our intraoral scanners, and come and talk to us. Thank you again.